All right, so in this video, we're going to talk about the inverses of one-to-one functions, okay? We just learned about one-to-one functions. Remember, a function has to be one-to-one in order to have an inverse, okay? So we're going to apply the inverse function property, which is this part right here, to determine if two functions are inverses, okay? In the subsequent video, we're going to calculate the inverse of a one-to-one function, and I'll show you how to do that, okay? So reminder, from 2.7a, in order for a function to have an inverse, it must be one-to-one, okay? So inverse function property states that we have f, a function f, okay? It has to be a one-to-one function with a domain of a and a range of b. The inverse function, okay, this notation is called f inverse, okay? This is not an exponent. It's a notation that you should understand to be the inverse of the function f, okay? It satisfies the following cancellation properties, okay? So we just learned about composition of functions. So if we have the f inverse of f of x, okay, when we find this composed function, it should be equal to x, okay? And that's going to be true for every x in the domain A, okay? We can also find the composed function f of f inverse, okay? And that should also be equal to x, and that's going to be true for every x in the range or the set B, okay? So in this video, we're going to verify that the two functions are inverses. And what we need to do is we just need to show that f inverse of f is equal to x. And I'm also going to show that f of f inverse is equal to x, okay? So that's what we're going to do in the three examples here today. All right, so we want to verify that these two functions are inverses. All right, so we've got two functions, f and g. Okay, and the first thing we want to do is we want to assume that g of x is the inverse. Okay, so we're going to call g of x f inverse of x. Okay, so now we've renamed g of x to f inverse. All right, so the first thing I'm going to do, the first part of this inverse function property, I've got f inverse of f of x. Okay, so f inverse is x to the 1/3, and I'm going to substitute x cubed, which is f of x, into this x, which is f inverse, okay? So I've got x cubed now to the 1/3 power, and I've got a power raised to a power, so I'm going to multiply those exponents. So 3 times 1/3 is 1, so f inverse of f of x is going to be equal to x, okay? Now let's use the second part, okay? I just want to show that f of f inverse is also equal to x, okay? So we're still calling g of x f inverse. This time I'm going to take this value, x to the 1/3, and I'm going to plug it in for x here, okay? So I've got x to the 1/3 raised to the 3rd power. So again, I've got a power raised to a power, so I'm going to multiply those exponents, and again, I get x to the 1st, okay? So that shows me that f of x and g of x here are inverses of one another, okay? Pause the video, give number 2 a try, okay? All right. So f of x is 2x minus 5, and I want to show that or verify that f of x and g of x here, which is x plus 5 divided by 2, are inverses of one another. Okay. Again, I'm going to call g of x f inverse, and the first thing I'm going to do is I'm going to take 2x minus 5, and I'm going to plug it in for x here, again, that composed function. Okay, so 2x minus 5 plus this 5 divided by 2. So I've got some algebra to do. I need to simplify here. So this negative 5 and this positive 5 are going to cancel out. That gives me 2x divided by 2. These 2's are going to cancel out, and magically there I get f inverse of f of x equals x. Okay. Now let's do it the other way just to show that this is true. Okay, we're going to let g of x equal f inverse again. This time I'm going to plug this into f of x for x here. So I'm going to have 2 times this ratio here, minus 5, okay? So these 2's are going to cancel out, so I'm left with x plus 5 minus 5. Well, these 5's cancel out, and I'm just left with x, okay? Because these are both true, f of x and g of x have to be inverses of one another, okay? Again, pause the video and give number 3 a try here. Okay, we've got f of x equal to this quadratic, x squared minus 4. Okay, we're assuming x is greater than or equal to 0 for this case. we've got g of x equal to x plus 4, square root of that, and our domain there is going to be x is greater than or equal to negative 4. So these domains are specified, okay? And we want to show that they're inverses of one another. All right, so again, we're going to let g of x equal f inverse. So the first thing I'm going to do is I'm going to take this value and plug it in here for x. Okay, doing a little math, these negative 4 and this positive 4 cancel out, so I've got the square root of x squared, and the square root of x squared is going to be x. Okay, and finally, again, we're going to let g of x equal f inverse. I'm going to take this value and plug it into x over here. Okay, when I square a radical expression, remember the radical goes away, so that gives me x plus 4, x minus 4. These 4's cancel out, and I'm left with x, okay? So these are going to be inverses of one another. The domains have to be specified this way. We'll go over that in a subsequent video as well. But notice you see that each of these, f inverse of f and f of f inverse, both equal x, okay?